Oh, and good morning, grade 9 with you, Mr. Samir, today with the second part of our lesson, structure of the nuclear atom. Now we are going to turn from the subatomic particles to the other part, talking about the structure of the atom and how it starts to be organized from inside. Atomic nucleus. How can you describe the structure of the nuclear atom inside? When subatomic particles were discovered, scientists wondered how the particles were put together in an atom. And most scientists, including J.J. Thomson, thought it likely that the electrons were evenly distributed throughout an atom field of a uniform with positively charged material. That means that the nucleus will be the whole atom will be solid structure. In Thomson atomic model, known as the plum pudding model, it's like a watermelon here. Well, the positive charge and the seeds inside will be the electrons. Electrons were stuck in a lump of positive charge, similar to raisins stuck in broth. All of atom turned out to be short-lived. However, due to the work of the former student of Thomson, Ernest Rutherford, was one of the smart people who worked over that. Yeah, he was born in New Zealand, and Rutherford was, you know, awarded the Nobel Prize for Chemistry in 1901. Or look at his portrait appear here on the New Zealand dollar, which is 100. Rutherford gold foil experiment was the revolution for the discovery of the atom structure from inside. 1911, Rutherford and his workers wanted to test existing embodying model of atomic structure for Thomson. Is it really here or not? They devised the gold foil experiment, and their test used alpha particles, which was, yeah, coming from uh, nuclear reaction that happen and radioactive elements. And the alpha particles, which are helium atom structure, like the helium in structure, that have lost their two electrons and have a double positive charge because of the two remaining protons. So in the experiment, a narrow beam of alpha particles was directed at a very thin sheet of gold. If you see here, guys, that will be the beam of alpha going straight line. According to the structure said by Thomson, all of that will be filled here by atom structure, and it will be uniform solid with no spaces. And that means that all of the alpha particle, when they start to be near the gold atoms, they will get positive charge of the protons inside the gold and get back again. But they discovered that not all of the beams are going to get back again and reflect. No, some of them start to penetrate through without any reflection, and some of them start to penetrate with a little bit diffraction here, and they start to go away in this way and this way. So they said that the atom wasn't uniform and solid and lump like what said by Mr. Thomson, and that was wrong model for Mr. Thomson. So they start to get that evidence for them, as according to that, it will be that we have here a lot of space inside the atom. And here that is the explanation for Rutherford about that, that there will be a lot of space inside the atom, and that if that it will be the atoms of gold, so inside there will be nucleus with a positive charge, there will be space here, and this space will give what? If the rays are going to move between these particles in the space without getting near the nucleus, will get to start to penetrate through without any problem. But if they get near the nucleus and start to collide with the nucleus, they will get reflection and get back again. But if the alpha particles get to penetrate and move beside the nucleus, there will be repulsion between the positive charge in the nucleus of proton and the positive charge on alpha. So they will get to penetrate, but with a little diffraction. Yeah, it will be hued. That's what we see here. That was surprising. A small fraction of alpha particles bonded to the gold foil at very large angles here. And also, some even bounced straight back toward the source. So, what did the scientists see inside the atom to determine the structure that are inside the atom? So, they use to work there and determine the structure inside of the atom by observing how the atom interacted with particles with known properties like negatively charged electrons or positively charged alpha particles here. And Rutherford atomic model based on this experiment of gold foil, and he suggests a new theory for the atom. He proposed that the atom is mostly empty space, thus explaining lack of deflection of most of alpha particles and they penetrate through without any deflection. Number two, he concluded that all the positive charge and almost all of the mass of the atom are concentrated in the small region in the center of it, and that's called the nucleus. So the nuclear atom here will get protons, neutrons are located in the positively charged nucleus. The electrons are distributed around the nucleus and occupy almost all of the volume of the atom. So accordingly, we will get, guys, the model that given the nucleus is tiny and dense packed compared with the atom as a whole. And if an atom were the size of full stadium, the nucleus would be the size of marble, and that's too small relative to the whole atom size. The nucleus is really too small. And Rutherford atomic model had to be revised in order to explain chemical properties of the element. So here, what evidence from Rutherford gold foil experiments disprove J. Thomson budding model? Rutherford observed that most of the particles passed through the foil with no deflection. That means there will be space there. And on the other side, we will get that Bloom-Banning model was not true about that because it said that most of the atom is a uniform solid Bloom-Banning model. Yeah. Let's know by the end that we get three kinds of subatomic particles are electrons, protons, and neutrons. Also, we knew that in nuclear atom, the protons and neutrons are located in the nucleus, and the electrons are distributed around the nucleus and occupy almost all of the volume of the atom. So mostly the electrons are getting most of the space there. Electrons are negatively charged subatomic particles, and the cathode ray is a stream of electrons produced by a negatively electrode or cathode of the tube containing gas at low pressure applied to it, high voltage electrical current. Proton, positively charged subatomic particles found in the nucleus of the atom, and neutrons, subatomic particles with no charge and mass of 1 AMU atomic mass unit found in nucleus of atom. And the nucleus is the tiny, dense central portion of an atom composed of protons and neutrons, and we have to know electrons and the structure of atoms. Atoms have a positively charged proton, neutrons inside the nucleus, and in the outside they have negatively charged electrons outside the nucleus, and the number of electrons is equal to the number of protons, so the atom will be electrically charged. Thank you for listening. Grade 9, be safe at home, and good luck.